So hello everyone. Today we are going to start with class 10 real numbers. Before starting the chapter, myself Danya from Arithmetica. This is first part of this real number. We will be discussing the chapter 1 real numbers over here. What are numbers and why we are studying the real numbers, why we are using it and how it will be. Okay? So we can start now. What are the parts that we are going to discuss over here? First is system of numbers. System of numbers. What are the system of numbers? For example, the first set of numbers is natural numbers. Then there comes whole numbers, integers. They are the pattern of system of numbers. Then we will be discussing the most important topic in real number, that is fundamental theorem of arithmetics. Fundamental theorem of arithmetic. Okay. Then we will be discussing about the problems based on fundamental theorem of arithmetic, and we will be revisiting what are irrational numbers. So hope we can start with the session. First, we can start with system of numbers. What is numbers? Numbers have a special character. Other than everything, numbers are the one where it has no end. It turns to infinity. No one can say which is the highest number in this world, right? So numbers are very special. First set of numbers is natural numbers. Why the name natural exists, you know? If I ask you to count or if I ask you to say the number, what you will people will be, we will be starting from 1, 2, 3, 4. So by nature, spontaneously, we people start with 1. And these set of numbers are said to be natural numbers. So natural numbers are generally denoted by capital letter of n. Okay, so natural numbers are the numbers which starts from 1 and it moves on infinity. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and so on 100 and so on 1000 and so on. So these can also be said to be counting numbers. We can count the numbers using our fingers or objects. Next comes whole number. When does these whole numbers exist, you know? We will be heard about predecessor and successor, right? What is predecessor? The preceding term or the before term, just before, right? What is successor? Just after, right? We people know in our mobile recharge and all we will be using prepaid, postpaid. What is prepaid? That we are using something which is done before. Postpaid, after that we will be paying the bill, right? So whole numbers exist like that only. Every number have their own predecessor. For example, what is the predecessor of 4? It's 3, just before term. What is about predecessor of 3? It is 2. Predecessor of 2, it is 1. So what is the predecessor of 1? 1 is the first counting number. What is predecessor of 1? That is 0, nothing. So whole numbers are the numbers where it starts from 0. 0 means it's nothing is there, or we can say it is an empty one, right? So whole numbers are the numbers that starts from 0, 1, 2, 3 and so on. In other words, we can also say whole numbers will be equals to 0 plus natural numbers. So whole numbers are the numbers where we can say 0 plus natural numbers, which means once we include 0 along with the natural number, it turns to whole number. Very simple. Okay, so 0, 1, 2, 3, 4, 5 and so on. Once we started taking the consideration into 1, it is said to be natural number. Once we include 0, it is said to be whole numbers. So why this arrow mark is here, you know? The arrow mark indicates these numbers are continuing. There is no end. It is traveling. It's not an end of this number line. Right? In our lower classes, we learnt all this. Ray, line segment, right? Okay, so next, integers. What is integers now? We know when we have negative numbers, or in simple ways we can say if there is one positive, obviously some negatives will also be there. Right. So if I started a business, I should expect not only profit, there might be a chance of getting loss also. Right? If I'm not studied for my exam, I should not hope for passing the exam. There might be the chance for getting fail also. Right? So everything have its negative replication also. What is integers then? Integers are the numbers where we have -1, -2, -3 and so on. Okay, so where we can say this integer 0 will be lying on the middle of the number line. Then right side of the number line will always be indicating positive integers. While we include the negative numbers, we can say that they are negative integers, -1, -2, -3 and so on. Generally, while we are trying to say the integers and all, we will be saying -3, -2, -1, 0, 1, 2, 3. But that's not the right way to say. Why, ma'am? Why so? Because whether the integer starts with -3? No, right? Whether it starts with -2? No. But we don't know the starting number, right? Yes, in such case, what we can do? While we are saying the integers about the numbers, we can say 0, plus or minus 1, plus or minus 2, plus or minus 3 and so on. While writing the integer set of numbers, this is the right way. But while we are saying, we can say in this manner 0, plus or minus 1, plus or minus 2, plus or minus 3 and so on. Okay, so what we can say in short, integers are the numbers where it includes negative numbers, positive numbers as well as 0. In integers, they will be whole numbers, they will be natural numbers also. Now comes rational number. What is mean by rational number? Ratio, division, or the name itself explains. Every number name says its property. So, rational number means we will be having numerator as well as denominator. So number which is in a form of P by Q. P is our numerator and Q is our denominator, right? Number in the form of P by Q, where P and Q are integers. These numbers can be integers also, where P and Q are integers and Q is not equal to 0. Our denominator can never be 0 because any number divided by 0 is not defined or undefined. Okay, that's why we are saying P and Q can be any number on the number line. But Q should never be equals to 0. What is that? Q, that is my denominator, should not be equal to 0. Whether the numerator can be 0? Yes, obviously it can. Because our property states only for the denominator. What it states? P by Q, P and Q are integers where Q is not equal to 0. Which means P can be 0, P can be positive, P can be negative. Next, Q. Q can be negative, Q can be positive, but Q can never be 0. That's the only condition. Examples: 1 by 3, minus 2 by 3 are rational numbers. Yes, as I said, P can be positive, P can be negative, P can be 0. Whereas Q can be positive, Q can be negative, but Q will never be equal to 0, where we say P by Q form. Next, all integers included in the rational number. Okay, every integer can be placed in the rational number. An integer z can be written as the ratio of z by 1. Very simple. For example, we can take the previous slide of this number line. Okay, I can write -3 as -3 by 1. Now see, it is in a form of P by Q, right? So every number can be represented as rational number because if nothing is there, it is divided by 1, which means it can be a rational number. Hope it is clear. Irrational number. Before moving to irrational number, I have a small question with you. Okay, observe each and every slide from the beginning. Not from this, from the beginning system of numbers. First we discussed natural numbers where we have n as a denotation. Then we discussed about whole numbers where we have the denotation w. Okay. Then we discussed about integers. We have z as our denotation or z, right? Rational number, q, quotient, yes, we have a denotation. But here we never used denotation. Why? Or what is the denotation to write this irrational number? This question is for you and you can answer it later. Okay. Irrational numbers. Those number when we can express in decimal form or neither terminating or repeating decimals are known as irrational number. Okay. We can make it very simple. Okay, very simple. What is terminating? Neither terminating or repeating. Terminating which is not coming to end, right? What they are saying is about terminating and repeating. Ma'am, then how about irrational? Very simple. Any number which cannot be represented in the number line is said to be irrational. We can't give the exact location for this number, right? So 3 by 10 cannot be expressed in number line. Any such numbers? Root 2, right? 1.414 and so on. Root 3, 1.732 and so on. Root 5 similarly. Pi value, if we take divide 22 by 7, we will be getting, right? It will be non-terminating decimal 3.14 and so on. So these are some examples of irrational number. So how we can find this irrational number? When the number which cannot be placed in the number line. Any number that cannot be placed in the number line is said to be irrational numbers. Again, I am reminding, there is a question for you. What is the denotation for irrational number and why it is used? Okay, real number or okay, the rational and the irrational number combined together are called real number. Okay, so what is real number? Real number or the real valued number. Is there any number which can be represented in the number line? Yes, it will be there. Positive number? Yes, it will be there. Negative number? Yes, it will be there. Zero? Yes, it is there. Any number which cannot be, which is neither ending, there is no end for the number, yes, it will be there. So it's a bank or it's a urn where we can find all kind of numbers. So real numbers are the numbers which includes rational number as well as irrational number. When we combine both the numbers, we can say they are together forms, real number. Real numbers is the form where it includes rational number plus irrational number. So what are real numbers? 2 by 3, 2 by 5, minus 3 by 7, root 2. So these first three numbers are, we can say, it is a rational. Root 2, root 3, root 5 pi values are said to be irrational. Now, we have some properties over here. The sum, the difference or the product of a rational and irrational number is irrational. So, what we are saying, if I add the numbers or if I subtract the numbers or if I multiplied a rational number, 1 minute, I will show you. I am taking a rational number and I am multiplying with an irrational number. How we used to multiply the fraction? As like that. 2 root 2 by 3. The sum, the difference or the product will be irrational always. Once the root value occurs over the number, while we are multiplying with some number or dividing with some number, obviously the result will be irrational. So 3 plus root 2 is irrational. 4 minus root 3 is irrational. All these numbers are irrational. While we are adding or subtracting or multiplying, they will be irrational. So this is what we describe. Real numbers is like a universe. In this universe, we have different kinds of people, right? As like in this real numbers, we have rational number, integer, whole number, natural number. But these are the parts of rational number. Other than that, any number which cannot be expressed in any of the above, as real, rational, as integer, as whole, as natural, such number have different name called irrational number. These number will also be categorized as real numbers. So real numbers will be having rational as well as irrational numbers. Now prime number, very simple, where we are learning from our childhoods, right? Okay, except one, each natural number which is divisible by 1 and the number itself is called prime number. 1 is neither prime nor composite. Why? Because every prime number can be expressed in two forms only, not more than two forms, not less than two forms. But 1 can be expressed in only one form, that is 1 into 1. But what we said, every prime number have only exactly two factors, which means in every prime number should be of two factors. If I took 2, right, what are the factors? 1 and 2, I have exactly two factors. If I took 3, I have 1, 3, right? 5, 1, 5, 11, 1, 11, right? So any number which has exactly two factors, one is the number itself and other is 1, such numbers are said to be prime numbers. Why 1 is not prime? Because one do not have exactly two factors. So what is 1? 1 is neither prime nor composite. Okay, what are the examples of prime? 2, 3, 5, 7, 11, 13, 17, 19. Have you observed this number once again? Except 2, no other numbers are even, right? Every even number have 2 as its factor. In such case, which means those number every time includes 2 as its factor, which results in more than 2 factors. That's why no other numbers which are even cannot be placed. So what is here? 2 is the only even prime number. 1 is neither prime nor composite. We saw that, right? There are infinite prime numbers. Yes, as long as there is no n for the numbers, we cannot say that there is an n for prime number. Now, co-prime. What is co-prime? A pair of two natural numbers having no other common factors other than 1. Such numbers are called co-prime. For example, 3 and 5 are co-prime. If we take 3, what are the factors of 3? 1 and 3. If we take 5, what are the factors of 5? 1 and 5. These two have only 1 as their common factor. Such numbers are said to be co-prime. So what are co-prime? Co-prime are the numbers which have no common factor other than 1. So 1 is the one and only common factor. It looks very deep, right? 1 is the one and only common factor. So if we take all these numbers, we can say they are co-prime. You may have a doubt. Ma'am, you took 5 and 6 here. Then, why are you including it as in co-prime? 6 is not prime, right? 6 is not prime. I agree with that. But what are the factors of 5? 1 and 5. What are the factors of 6? 1, 2, 3, 6. Right? Because 6 can be expressed as 1 into 6, 2 into 3, 3 into 2, 6 into 1. So the factors are 1, 2, 3 and 6. In such case, they are not prime. Yes, but they have only 1 as their common factor. That's why we are saying these numbers as co-prime. Twin prime. Twin. What is the meaning of twin? 2. Right? Twin babies. Right? Now, prime numbers differing by 2 are called twin primes. Take this set of numbers 3 and 5. 5 minus 3, 2. 5 minus 7, 2. So the difference of the number is 2. When I am taking a set of number, if the difference is 2, I can say that as twin prime. Twin prime means the difference equal to 2. The difference between the numbers will be equal to 2. Composite numbers. What are composite numbers? All natural numbers which are not prime except one are said to be composite. Very simple. Other than prime number. 1 is neither prime nor composite. It is special. 2, it is prime. 3, it is prime. 4, it is not prime. Why? 4 can be expressed as 1 into 4, 2 into 2, which means 1, 2, 4 are the factors of 4, which means it has more than 2 factors. What is the condition of prime? It has exactly 2 factors. But here we have more than 2 factors. That's why we are saying it as composite numbers. So what are composite numbers? Any number which has more than 2 factors, we can say that they are composite numbers. So how about 5? No, 5 has only 2 factors, 1 and 5. How about 6? 1, 2, 3, 6. 6 is composite because we have more than 2 factors. So if C is a set of composite number, then C can be 4, 6, 8, 9, 10, 12 and so on. If you observe all these numbers have more than 2 factors. That's why we are reasoning it as composite number. These are all recalling system of numbers. What is composite number? What is prime number? What is co-prime number? What is twin prime number? These are all just so far we have been recalled what we learned so far. Now we are entering to the topic. Please stay focused. Fundamental theorem of arithmetics. What does this theorem state? Fundamental theorem. Relation between composite numbers and prime numbers. So what is theorem? The goal of this theorem, it shows a relation between the composite numbers and prime numbers. What is that? Every composite number can be expressed. Every composite number can be expressed as a product of primes, and this factorization is unique apart from the order in which the prime factors are occurred. For example, what does it say? Very simple, okay. If I take any composite number, every composite number can be expressed as prime, right? How? For example, I am taking 120. 120 can be expressed as 2, 230, again 2, 15, 5, 3, 5, 5, 1. So 120 equals to 2 into 2 into 2 into 3 into 5, which means 2 cube into 3 into 5. Suppose if I write 5 into 3 into 2 into 2 into 2. Again, I can rewrite it as 5 into 2 into 3 into 2 into 2. Right? So, every composite number can be expressed as product of prime. I can express each and every composite number into the product of primes. Okay, and this factorization is unique. Every composite numbers have different factors. We don't want to consider the order. What is order? At first, I wrote 2 into 2 into 2 into 3 into 5. Right? But for the next time, I wrote it as 5 into 3 into 2, 2 and 2. Right? Then I wrote it as 5 into 2 into 3 into 2 into 2. So here the order differs. First I took 2. Some of you may take 5. Some of you may take 3 at it first, right? Which means everyone will get different order. But it doesn't matter. Okay. In which the prime factor occur. But everyone we will be getting the same answer only. 2 cube into 3 into 5. So what does this theorem state? Every composite number can be expressed as product of prime, and this factorization is unique, right? For example, here we got 2 cube into 3 into 5, right? Now I'm taking other number, okay? Okay, now I'm taking 64. 2 table 32. 2 table 2 ones are 2, 2 6 are 12. 2 table 4, 2 table 2, 2 table 1. Every time, only thing we need to take care is whatever factor I'm choosing, it should be prime. That's the one and only rule. Okay, so 64 can be expressed as 1, 2, 3, 4, 5. 2 to the power 5. Which means every factorization is unique. For 120 I got 2 cube into 3 into 5. For 64 I got 2 power 5. For 100 I will be getting something else. So every time what happened, the factorization seems to be unique, where the order doesn't matter. This is what fundamental theorem. What does fundamental theorem says? I'm taking a composite number. I'm finding the product of primes. Okay, choosing a composite number, finding the product of primes. Okay, and this prime factorization will be unique. I don't want to consider the order of this number. This is said to be fundamental theorem of arithmetic. HCF and LCM of numbers. HCF or else GCD. What is HCF? Highest common factor. What we used to do, first we will be finding the factor of the number, factor between the two numbers. Then we will be choosing the common one. In that we will be taking the highest value. Just reverse the one. Okay, our steps are like reversing, right? So HCF of two numbers is the greatest number that divides each one of them exactly. I will show you with an example. Okay, least common multiple. You just take the order alone. First I will be finding factor. From that I will be picking the common one. In that I will be choosing the highest value. Okay. LCM, least common multiple. I will be finding the multiples. In that I will be choosing the common one. In that I will be finding the least value or the lowest value. HCF and LCM of number. HCF equal to product of smallest powers of common factors. LCM equals to product of highest powers of each prime factor. So product of two numbers equal to HCF into LCM, which is very important one. Product of two numbers equal to HCF into LCM. Just make a note of that. Find the LCM and HCF of 6 and 20. 6. What are the prime factors of 6? 2 into 3 into 1. 1 is not mandatory to write. Next is 20. If I take 20, 2 table 10 times, 2 table 5 times, 5 table 1 time, right? So, 2 into 5, which means 2 square into 5. Okay, this is one of the way to write, but if I take 6 is equal to 2 into 3, 20 equal to 2 into 2 into 5. So only first I find the factors, then I took the common one. The common one is only 2, so the HCF is 2. Okay, or else we can say it is the smallest power of a common factor. The smallest power is 2 here, right? And the common factor is also 2. Now, easiest way to find HCF. Now, how we can find LCM? LCM, 2 into 3 for 6 and for 20, 2 into 2 into 5. So, 2 square we can say, or else we can say 2 into 3, 2 square into 5. Which is the highest power, 2 power 1 or 2 power 2? 2 power 2. Take that. 2 power, I am writing here, 2 power 2 into 3. I am having only 1 3, so I should take that. I am having only 1 5, I should take that. So 2 square into 3 into 5, which is 60 is our LCM. Find the LCM and HCF of 6 and 20 by prime factorization method. So this is what we did. Now find the LCM and HCF of 96 and 404 by prime factorization method. Once they mention the method, we are supposed to use only that method. I am taking 96, 2 table, 48, 2 table, 24, 2 table, 12, 2 table, 6, 2 table, 3, 3 table, 1. 1, 2, 3, 4, 5. 2 power 5 into 3. Similarly, for 404, we can take here 404. First 2 table, 202. Again 2 table, 101. 101 is the prime number, so we can stop here. So 2 square into 101. Now comes LCM. 2 power 5, 2 square. Which is the highest power? 2 power 5. So I took 2 power 5. Then we have only 1, 3. We will be taking the 3. We have 101. We will be taking that also. Multiply all those values. We will be getting 9696. Okay. I will show the multiplication here. So 2 power 5. What is 2 power 5? 2 into 2 into 2 into 2 into 2. 2 2s are 4 2s are 8. 8 2s are 16. 16 2s are 32. 32 into 3 into 101. 32 into 3. 3 2s are 6. 96 into 101. 9696. Now comes HCF. HCF we will be taking only the least power. So 2 square, which is 4. Okay. So while I'm explaining the problem, you just try by yourself taking in your note. Find the HCF and LCM of 1296 and 2520 by prime factorization method. So if you observe, all the numbers we took here is prime factors, right? First for HCF. 1, 2, 3, 3 pairs of 2, 2 pairs of 3. That's all. So 2 cube into 3 square will be our HCF. For LCM, we will be choosing the highest power, right? Like 2 power 4, 2 cube. Which is the highest power? 2 power 4. So I took 2 power 4. 3 power 4, 3 square. Which is the highest power? 3 power 4. 5 and 7, we have only 1. So that will be the highest power. So 5 into 7. Multiply all those values. We will be reaching to our LCM. Okay. Next problem. Given that HCF 306, 657 is 9. We need to find the LCM. Okay. So what are the two numbers? 306 and 657. What is the HCF? HCF is 9. What I need to find? I need to find LCM. For this we learnt a formula, right? Product of two numbers equal to HCF into LCM. What are the product of two numbers? 306 into 657 equals to 9 into LCM. By transposition method, while we are taking this 9 to the opposite side, multiplication turns to division. So 306 into 657 divided by 9 equal to LCM. So we can use the divisibility rule, right? 33 plus 0 plus 6 is 9. Divide by 9. So these two numbers will cancel each other. 3, 9 3s are 27. Remaining 3. 9 4s are 36. 9 1s are 9. So now we just need to multiply. 34 into 657. 657 into 34. 7 4s 28, balance 2. 5 4s 20 plus 2 22, balance 2. 24 plus 2 26. Again 7 3s 21, balance 2. 15 plus 2 17, balance 1. 18 plus 1 19. 8 3 3 2 2. Right? So 2 2 3 3 8 or 22,338. Now this is the concept of fundamental theorem of arithmetics. First we learned the fundamental theorem of arithmetics. Then we used to solve the problems based on fundamental theorem of arithmetics. Now our topic is revisiting irrational number. Now we are going to have a dust up. Okay. What are they? First, those number which can be expressed in a decimal form, neither terminating or repeating decimals, are said to be irrational. So terminating, there is no end of the number. Repeating, the same number is being repeating for the long while, right? Such numbers are said to be irrational number. What is the other method I said? Any number which cannot be expressed in the number line is said to be irrational number, which means a number which cannot be located on the number line, or there is no exact position on the number line. Such numbers are said to be irrational numbers. Examples are root 2, root 3, root 5 and pi. What is pi? 22 by 7, right? Or 3.14 and so on. They keep on moving, right? Which cannot be expressed. Then one theorem is there. What does this theorem state? Let p be a prime number. I'm taking a prime number and I'm naming it as p. Okay, if p divides a square, so if p divides a square, p is a prime number that can divide a square, then p divides a, where a is a positive integer, and other than positive integer I have no other values. Okay, so let the prime factorization can be follow. What we can say? A equals to p1, p2, p3 and so on pn, where p1, p2, p3 are primes, not necessarily distinct or not necessarily different. Okay, so what we can say? Now we given that p divides a square, which means from the fundamental theorem it follows that p is one of the prime factors of a square, right? P is one of the factor of a square. So using the uniqueness part of fundamental theorem, what we can say? We can say only prime factors of a square are p1, p2 and so on pn, which we wrote a equals to, right? So p is 1 of p. What is that p? P is one of the value from p1, p2, p3 and so on. So first what I'm taking? I'm taking a equals to p1, p2, p3 and so on pn, which means p divides a. This is the uniqueness of theorem. Revisiting irrational number, root 2 and root 3 are irrational. 3 root 2, once the root value occur, it is irrational. 2 plus root 3, irrational. 5 minus root 3. So, sum of rational and irrational is irrational. Difference of rational and irrational is irrational. Sum of two irrational is irrational. So, root p plus root q is irrational, where p and q are prime. Even if it is a prime and if it is in a square root, we can say they are irrational. What are the final points? FTA, fundamental theorem of arithmetic. Every composite number can be expressed as a product of prime, and this factorization is unique apart from the order. So in fundamental theorem we never consider the order. We will be taking only the prime factors and each factor will be unique. Product of numbers will be equals to HCF into LCM. This property is very important while we are solving the problems. So what we learned so far? In this part 1 we discussed about system of numbers. What are the system of numbers? Natural numbers, whole numbers, integers, rational numbers, irrational numbers and real numbers. We discussed about all this. Apart from this, we also discussed about prime, co-prime, twin prime, composite numbers. Once we recall all this only, we can be very clear with fundamental theorem of arithmetics. Then we solve few problems based on fundamental theorem of arithmetics. Then we discussed about few properties or the sum, difference and the product of irrational numbers. In the next video, we will be discussing about again what are irrational numbers, what are their properties and proof for irrational number. Every time in maths, once we give it as a statement, it can never be agreed. For every statement, there should be the proof. So the proof of irrational should also be there. That we will be discussing in the next video. So thank you. Hope it is clear. The one question which I raised with you is irrational number. What is the denotion of irrational numbers and why it is? Find the answer for this and let me know. Thank you.